If there is a magic on the planet, it is contained in the water. Hey, I am Ghulam Raza with my groupmate Izzat Ali, and we are going to deliver a final year presentation on the topic solar water distillation unit for drinking water purification system for remote areas. This is the flow of our presentation outline. First of all, we will discuss introduction, then motivation, then problem statement, literature review, aims and objectives, methodology, result and discussion, conclusion and future recommendation. As we know that water sources have been shrunk day by day, and we people cannot survive without water. It is a basic need. The most basic necessity of human existence on earth is an abundant supply of potable water. The available fresh water on earth is limited. More than two-thirds of Earth's surface is covered with water, but more than 97% of available water is either salty or polluted. As we have the amount of water available is in the salt form or it is a polluted. So we cannot drink the polluted water or salty water. So we need to purify it, or we need to develop a method which can purify it. And around 2.6% is a fresh water. Less than 1% of fresh water is within reach of human and other organisms. 785 million people lack even a basic drinking water service, including 144 million people who are dependent on surface water. This is a survey which was conducted by the World Health Organization. According to this survey, 1 in 2020, 1 in 4 people lacked safely managed drinking water. In 2020, 107 million people gained access to safe drinking water at home. By 2030, at this rate, 1.6 billion people will still lack safe drinking water at home. So based on these results, we can see that situation is moving towards alarming. Motivation. Desalination, a costly means of providing fresh water. These are few techniques which are called membrane techniques, in which we use membrane to purify water. Is we know that if you are not drinking the purified water or safe fresh water, then you are likely to prone skin diseases or water diseases or cancer diseases. So it is very important or essential to drink the purified water. First of all, there is a MD, which is called membrane desalination, in which we use a thin sheet of membrane to purify the water. It is efficient, environmental friendly. It does not pollute the environment, and it has a high cost. It is very costly because the active components. Solar energy is not used. MED, this is multi-effect desalination, in which water is passed from various stages for purification. This is also efficient but costly and less energy efficient. It consumes a lot of energy. Reverse osmosis. It is also a process in which water is passed through a membrane, but the flow of water is reversed. It is, passed through an external force or pressure. You can call it as simply pumping, through which it is passed. That's why it is called a reverse osmosis. It is very efficient but most expensive. Solar distillation. It is energy efficient, easy to construct, cost effective. As we have discussed in a previous slide, that the techniques used for purification of water are not expensive, are not cheap, but the technique used called solar water distillation used for purification purpose is a very much, you know, cost effective. So this is the basically motivation to use the solar water distillation. Is the water sources have been declined day by day, in the need of water is, growing exponentially. So this is a, great problem, or you can say that this is a major problem that world will face. So we have to tackle that a problem. So we have, actually, this is our problem statement, which defines that the demand of fresh water is growing rapidly, and this issue will become the worldwide challenge. Around 700 million people in 43 countries suffer today from water scarcity. By 2025, 1.8 million people will be living in countries with absolute water scarcity, and two-thirds of the world's population could be living under water stress condition. UN research. The current distillation technologies are expensive, and other people living in rural areas can't afford it to buy. The solar water distillation is cheaper than other existing technologies because the sun's energy is absolutely free. So this system can have no cost energy supply, and if the situation allows it, the system can function entirely on solar radiation in perfect environment. This is basically our literature review. There are some papers through which we have gone. First of all, the first paper actually describes, or tells us that when you increase the solar collector area, the productivity will be increased. And in the second paper, double basin, triple basin, and stepped solar still with reflectors gave higher distillate output with lowest production cost. So these are few papers which we have read and gained some knowledge. Aims and objectives. The aim of Earth is simply to produce a fresh water from groundwater and surface water. And under this aim, we have certain objectives which we have to achieve. First of all, we have to develop a solar designation prototype that could produce distilled water by using only solar energy, and to collect use different water samples in order to make it drinkable. What we will actually do that we will take samples from different areas, and different samples, ground groundwater samples and surface water. Methodology. How actually does it work? A solar distill water with substance dissolved in it by using the heat of sun to evaporate water so that it may be cooled and collected. As I want to explain it here, that when solar radiation fall on this basin, so heat is generated. So this collector, or glass is heated. The water available in this basin is heated. When it is heated, the evaporation occurs, and that vapors flow from this glass through this fresh water tank. They flow from this path, actually follow this path, and collect in this fresh water tank. And the seawater, or the water which is going to be purified, is passing from this path. Water comes from air, enters in the basin, and then it is purified or distilled. Then it is collected in this fresh water tank, and the contaminants come through from this path and collect in barren tank. So actually, this project works on the hydrological cycle, in which there are some process, like water is passed from various stages. First of all, it is evaporated, then there is a transportation, then precipitation. These are few stages from which water is passed. Methodology. As we discussed, that dirty water enters in the solar still, and the input of this project is solar energy, and dirty water comes in a solar still. Solar energy heats, that water, and it is evaporated, then condensate, then it is in a fresh water. And the residue is a, contaminants, or the water which remains in the bottom, or the contaminants which remains in the bottom of the basin, which is called a residue. Methodology is still continued. Basin. These are few, you can say that parameters, or characteristics of components which we have used. Basin. Volume of basin is 2.5 cubic foot. It could occupy around 70 liters of water, but we will fill it up to 20 to 25 liters in order to maximum output. As we increase the amount of water, then the water will take a lot of time to evaporate. As this is a simple rule of thermodynamics, that if we fill the tank completely, then it does not have a space for evaporation. So in order to maximize the efficiency, we have to fill up to 20 to 25 liters. And water tank, volume of water tank is 3 cubic foot, and it could occupy 70 liters of water. This is our design, SolidWorks design of proposed scheme. We have designed this, form, or this soft form, in the software SolidWorks. This is our hardware project, or the, you can say that final setup. Results and discussion. As we have discussed that we have taken some, parameters. We are going to test or analyze these three parameters: biological, physical, and chemical. These are few parameters. This is a table which is provided before the distillation. This is a table of groundwater samples before distillation. Sample 1, sample 2, sample 3, sample 4, sample 5. Actually, these are groundwater samples. Sample 1 shows some specific area, like, this is the sample 1 is a physical hostel from we have collected the groundwater. Their data is presented in this table. Sample 1, these are few, parameters. In physical parameters, we have color. It was colorless, okay, and it was normal. Taste was normal. Odor was odorless. Turbidity was 1.16, and TDS was 1350, and pH value was 7. Total hardness ppm SCO CO3 was 200. So these are few, the results which we have taken before the distillation. And S2 represents, Bihar. Bihar is the area from we have collected, area of Sakkar from we have collected the groundwater samples. And this is a WHO guidelines. WHO guidelines are standards which must be met by these results. You can see here some values are in red color. Those value are red color are actually violating the WHO guidelines. So, like, you can say that pH value is 777, and WHO suggests that it should be 6.5 to 8.5. If pH value is a 9 or 10, so it must be purified, or it must be rectified for safe drinking water. So this is a sample 1, sample 2, sample 3, sample 4, sample 5. So taste was saline. Here you can see that the value which are in red color actually needs to be purified or needs to be rectified. And this is our result once after the distillation. Groundwater samples after distillation. The table you saw in the previous slide was actually representing the results before the distillation. Once we distilled, it met all the requirements which are suggested by WHO. Like you can see that taste was normal here. First of all, it was saline, but when we purified it, it became normal. And like TDS 13,050 was for sample one. Once we purified, it became 54. So wow, it seems very efficient. So these are graphs which we have made in also software. These graphs are made with the help of this table. This graph are nothing but representing this tabular form into graphical form. Like groundwater sample S1, S2, S3, S4, and at y-axis we have TDS before distillation, and here turbidity NTU before distillation for physical parameters, and these graphs are for chemical parameters and chemical parameters. So this is surface water samples before distillation. As we discussed in previously, the groundwater samples. Here we have surface water samples before distillation. Here we found the problem or issue in only turbidity. Like sample 1 has 106 and sample 2 has 174. So we need to rectify these. So once we distilled it, it fulfilled the requirement provided by the WHO. These are also graphs. You can see that the green line shows the productivity and the red line shows the irradiance. As you know that irradiances are obtained from the sun. So at 3 p.m. productivity is a maximum. You can see that it is about 50 50 milliliter, and these results are without flat plate collector. It means flat plate collector is removed from that setup, from that project. But when we included the flat plate collector, the productivity was increased. First of all, it was 50, around 40. Here you can say that it is around 40. But when we included the flat plate collector, it increased up to 63 or 62. So you can see that how important flat plate collector is. So productivity gradually increased once we included the flat plate collector. And this graph shows the temperature of glass and temperature of water. The time is shown on the x-axis, and at y-axis we have a temperature. Temperature of water at 3 p.m. is actually, here you can 50 centigrade. These results are taken actually into the month of August or June, July. So temperature was very high. Conclusion. Conclusion is that our proposed scheme of solar distillation is one of the most highly effective process of cleaning up water to provide safe drinking water. Solar distillation is a cost-effective, socially viable, and sustainable techno-management solution for solving the problem of water scarcity. It is an energy-efficient, robust, easy to construct and maintain, and cost-effective. That's why it is very beneficial for the model. As we have discussed previously, that this project do not consume any external energy. It works on the solar energy. It is a natural process which is not costly, and it is a very much efficient also, and it is easy to construct. One can make it in in his or her home easily and meet the need of water. Recommendations for the future extension of the proposed prototype, following work can be done to make proper insulation of basin in order to reduce the heat loss. Once insulation is made properly, that heat will not be lost. Once heat is not lost, the evaporation rate will be increased and the productivity will also gradually increased. To increase the size of prototype in order to get more output, you can increase the area of solar collector. Once you increase the area of solar collector, so the temperature will also be increased and output will be also increased. Make it double slope solar still to increase still efficiency. As you saw, the we have designed a single solar still, and double solar still is quite like that. Simple is like this, there is the one slope, and double is like from both sides. And to use an appropriate solar collector in order to increase the wastewater temperature. To use sensors in order to monitor the different water parameters, as we can use a sensor for monitoring, which can tell us the output of from second to second, and we can act accordingly. Thank you very much.